And welcome to State of Cloud Native, brought to you by Platform 9. I'm Dawn Hoefferle, and we're going to give everyone just a couple of minutes here to join. We do have, we're starting just maybe 30 seconds early, so we're going to give everybody just a couple of minutes to join us here on the stream. And we are streaming this morning on YouTube, on Twitch, on LinkedIn. We're also over on Twitter, so you are hopefully joining us on one of those. And this live stream will also be available recorded as well afterwards. So if you miss any of it, please feel free to look us up on any of those channels as well. And you can check out everything that we talk about today, from the discussion on Kubevirt, as well as the demo that Anmol is going to give us in a little while as well. All right, I'm going to go ahead and introduce our panelists this morning. So we have Janakiram MSV. Good morning, Johnny. How are you?
Hey, Dawn. Doing great.
Evening for you, actually. And Johnny is a industry analyst with a focus on cloud native, edge, and so forth. And so he's been gracious enough to join us today for our live stream. He was on with us in January as well. And then sorry, go right ahead.
No, I said great to be a part of this again.
Awesome, thank you. We also have Anmol Sachan. Anmol is a product manager here at Platform 9, and we are really pleased to have him. He is a veteran of the State of Cloud Native. He's been on with us before, and we're really pleased to have him again. So welcome, Anmol.
Hey, thank you, Dawn. It's a pleasure to be back.
Wonderful. Well, I am going to step out of the way and let these two experts go ahead and talk. Today, we are talking about leveraging Kubevirt to bridge the VM container modernization gap.
Awesome. Dawn, can you enable the presentation for me to present? Excellent. All right, folks, great to be back on this panel, the State of Cloud Native, hosted by Platform 9. So we have a very interesting topic today, and this is a deep dive. We had a webinar with one of the senior leaders from Platform 9, and today we are excited to bring a deeper dive behind the scenes and some great demos lined up for you. So Kubernetes, as we know, is a successful distributed computing platform. If you're familiar with any distributed computing platform, Kubernetes is no different. It has a control plane, and then it has multiple worker nodes. You submit a job. A job technically is anything that you want to schedule, like a set of containers to the control plane, and the control plane will figure out which of the nodes are ideal and well suited for that workload, and will do the magic of scheduling your job as a set of pods or deployment on one of the nodes. This is a standard architecture. A lot of us are familiar with this, and this has been how Kubernetes was initially designed, and it has been evolving. The number of workloads that we know have increased. You can create cron jobs, you can create daemon sets, you can create stateful sets. A lot of new workloads have evolved, and it has literally become the de facto standard for running modern workloads across the cloud, the data center, and even at the edge. Now, there is an interesting phenomenon that is currently taking place, and that phenomenon is basically turning Kubernetes into a universal control plane. Now, what do I mean by universal control plane, and what is this evolution all about? Now, as an industry analyst, I keep an eye on some of the evolving and emerging trends. And one of the trends that I am noticing is Kubernetes is becoming the API endpoint for almost any infrastructure that you're dealing with. There are multiple trends that are kind of pointing towards this shift, this moment. So Kubernetes was originally designed to orchestrate containers. And as we know, there are certain standards that have been defined. For example, the container runtime interface, or the CRI, has been the core layer that enables Kubernetes to deal with containers. For example, when you're running a Kubernetes cluster in a typical default configuration, you have the CRI on every node, which is interfacing with the kubelet, and the kubelet basically talks to the runtime, managing the life cycle of containers. So the CRI is the layer between Kubernetes and the underlying container runtime. There are multiple container runtimes that we are familiar with. For example, container D is the default. Moby or Docker is the other one. And then there are other container runtime environments like Podman and Cryo and so on. Interestingly, all of them expose a similar interface for the kubelet to deal with the lifecycle of containers. So there is nothing new about it. It has evolved, it has become very stable, and this is how Kubernetes functions. And interestingly, this CRI interface has evolved to enable newer things. For example, kata containers is a very interesting trend where you basically bring up a new VM to run a container, because Kubernetes doesn't provide us multi-tenancy. What we actually see is one container being placed in one VM, one host. And Kata container runtime is also exposed as a CRI interface. So it becomes very interesting. So when you actually schedule a pod and say, hey, this has to be a Kata container, Kubernetes will talk to kubelet, and kubelet will talk to the Kata container CRI interface, quickly spins up a lightweight VM and puts a container inside it so that you have a sandbox and a very isolated container. The reason why I'm sharing this with you is how this CRI has evolved. And there are new runtimes that are coming up, like Wasm, the WebAssembly runtime, and that is also picking up a lot of momentum and a lot of interest among the cloud native community. But that is everything to do with containers and how CRI has become the standard layer for interacting with containers, and Kubernetes is best known for orchestrating containers. But the other trend that we have seen in the last couple of years is the rise of cloud-specific operators. Now, if you look at some of the major cloud providers like Azure, AWS, and Google Cloud, all of them have built operators that can be deployed in a Kubernetes cluster to manage the cloud resources, typically managed by these hyperscalers. For example, Amazon has built something called AWS controllers for Kubernetes. And by creating a YAML file, you can effectively provision an RDS database. You can initiate a snapshot. You can restore from a snapshot, or you can provision an EC2 instance, all by defining a YAML file, the definition of your cloud resource in a YAML file, and submitting that to Kubernetes. And Kubernetes will simply route that request to one of the operators that is specific to the target cloud that you are dealing with. And then that does the negotiation with the cloud provider API and ultimately manages the lifecycle of the managed resource. So what this actually means is Kubernetes is now it's extended beyond managing the lifecycle of containers to managing the lifecycle of cloud services, like cloud managed databases, even Hadoop clusters or object storage buckets or block storage devices. Basically, every service is now available as a YAML definition that can be submitted with kubectl. Now, obviously, these operators or the controllers are very specific to every cloud, and these are typically developed and maintained by cloud providers. For example, ACK is one such example, and Google has something called config controller, which is called the KCC, Kubernetes Configuration Controller, that is Google specific implementation. Just like we have Terraform, and then we also have things like CloudFormation and Google Cloud Deployment Manager templates, and Azure Bicep. There is a new standard that is coming up, which is outside of any of the cloud providers' implementation, which is a generic, neutral, open source implementation that is called Crossplane. So Crossplane is becoming the Terraform of Kubernetes, Terraform for Kubernetes, to deal with the cloud-based managed services. So if you use Crossplane, you can effectively leverage Kubernetes to deal with managed services of your choice without the reliance on the cloud-specific controllers like ACK or KCC, which are coming from the hyperscaler. So think of Crossplane as the open source implementation of these operators, but that is maintained by the CNCF community and not specifically a cloud provider. So this is a very unique opportunity for the ecosystem to build something that is completely open and governed by a larger technical committee and follows the CNCF process. So what does it really mean? So what it actually conveys is Kubernetes is going beyond managing containers, and now you can set up a Kubernetes cluster and also use it to manage the lifecycle of cloud resources. And combine that with GitOps, you have a very, very powerful mechanism of managing the lifecycle of databases, object storage, buckets, block storage devices, pretty much every building block of the cloud provider through Kubernetes. And then what is very interesting is bringing virtual machines into this fold. Now, effectively, if you look at the infrastructure landscape, there is no doubt and there is absolutely no debate on three different silos that we are dealing with. One silo is the public cloud. Now, the other silo are the modern microservices-based apps developed using containers and Kubernetes. The third silo that's been available to us for a long time, and that's been the digital backbone of enterprise, and those are the legacy applications like SAP, PeopleSoft, Oracle, SQL Server, DB2, a lot of legacy databases and very specific applications that are homegrown line of business applications, and they cannot be very quickly modernized. You cannot decompose them, you cannot break them down into containers and quickly turn them into microservices. They are too big to fail. They are too big to be modularized and composed as microservices, and they need to live in data center. So the best mechanism is to move them from bare metal servers into virtual machines. So virtual machines are available or running in the data center, and then you have the modern applications running in Kubernetes clusters. But they're still three different silos. One is the cloud, the second one is the modern applications, and the third one is VMs. Now, how Kubernetes is evolving to become the universal control plane is by bringing all these three silos under its fold. So there is a technology which has, again, become very popular, and there are a lot of contributors, there are a lot of consumers, and there are a lot of enthusiasts contributing to this project, and that is called Kubevirt. So what Kubevirt does is it basically brings virtual machines into Kubernetes fold. So technically, you can actually do kubectl get VMs, and you can treat VMs like pods. And not only that, by moving your legacy workloads into VMs and bringing them into Kubernetes via Kubevirt, you can perform interoperability between your modern workloads and legacy workloads. And they will actually share the same context. So you can expose endpoints and you can talk to them. One of the classic examples that you can think of is a very modern elastic microservices application using, built using Go and languages like Rust, but talking to a 20-year-old database, that is managing the supply chain of the organization. So this database, which is holding the inventory and the supply chain, is running in a VM, registered as a Kubevirt virtual machine inside Kubernetes, exposes its endpoint to a set of pods running as a deployment, as a replica set, and they talk to this endpoint without knowing that they're talking to a 20-year-old database running inside a VM within Kubernetes. For them, it is just yet another load balancer endpoint, and they talk as if they're talking to a native Kubernetes service. That is the beauty of bringing Kubevirt-based virtual machines into the context of Kubernetes. So I don't want to steal the thunder that Anmol is going to show. He has some interesting demos lined up, but you can imagine the power of bringing virtual machines and pods into the same context and making them talk to each other. And you add cloud to the mix, you pretty much have Kubernetes becoming the universal control plane and one API to deal with all the three infrastructure elements: the public cloud through Crossplane, containers through CRI, and virtual machines through Kubevirt. So that is what I want to leave you with. Again, I am trying to paint the big picture and give you an outside-in perspective of what I am saying. So this is where Kubernetes is transforming to becoming a universal control plane. And with that, I want to hand it over to Anmol, where he will walk us through a set of demos. And I'm going to come back and ask him questions on what we are going to see. So Anmol, all yours. Very excited to see what you have built so far.
Hey, thank you, Jani. So probably for everyone, I'll just give a
Anmol, I
quick
think you're
introduction.
muted.
Hi. Am I audible now? Can you hear me? Am I audible now to everyone?
Yes, you have been audible.
Okay.
Yeah, go ahead.
Okay. So yeah, hi. Thank you, Johnny, for that. For setting the stage. I think what you just told, I think it gives us an absolute big picture. And I'll just give a quick introduction of myself. Hi, I'm Anmol. So I work as a product manager at Platform 9. I lead the Platform 9's managed Kubernetes and Kubevirt offerings. And let's quickly dive. So, and I'm here to show you the platform 9 multi-cluster solution, and let's look at what are the new Kubevirt capabilities that we have added in the platform. So I'll quickly share my screen and we'll start from there. So is my screen visible?
Yes, it is visible. You can go ahead.
All right, thank you. So this is the Platform 9 managed Kubernetes platform, and an ability to run your workloads across all the different streams, which Jani said, as public cloud, your virtual machines, and your am I still audible, by the way?
Yes, Anmol, go ahead. You're audible.
Okay.
It's pretty clear.
Okay, awesome. All right. So let me quickly take you through the platform itself. So the platform lets you manage your multiple cluster across the public and private clouds. And it's divided into different spaces, or we call them as apps. So here you will see that we have infrastructure, Kubernetes, Kubevirt, Multicube, Argo CD, and other and settings, right? So the infrastructure pane gives a Kubernetes admin a complete view of what their whole infrastructure. So how many clusters they have, how many nodes, they can tag their favorite clusters. So let's have a quick look at the clusters, right? So here I have 2 clusters attached to my platform right now, and I can manage these clusters directly from the platform itself, right? And from here, you can, as a Kubernetes admin, you can add clusters pretty quickly. So we support creating clusters across virtual machines, physical nodes, AWS, Azure, and also you can import clusters from external providers, which you have created separately from Platform 9. So let me take you quickly to the Kubevirt space, which Johnny introduced us with, right? So Kubevirt as a technology enables users to run virtual machine across the Kubernetes cluster and along with containers, right? So this is the Kubevirt dashboard, which gives a user a quick view of how many clusters they have on which Kubevirt is working, how many nodes it's currently supported, and all other information such as storage. Along with this, you see how many virtual machines and VMIs you have currently on your cluster. Now let's quickly look at the virtual machine list, which shows you the current virtual machine that as a user you're managing on the platform, right? So here I have 2 machines. One of them is running and one of them is in a stop state. This actually gives you a quick view of the virtual machines you have, if they're running or not, if they're stopped, or if they have any issues, then you can go and debug these machines quickly. So what I'm going to do here, I'm quickly going to create a new virtual machine. And as Janice said, from just using a YAML, and which will appear here. So let's quickly look at that. So here I have a virtual machine definition in form of a YAML. So this is going to be a CentOS virtual machine, which is in the format of a Kubernetes spec, and I'm going to take a KVM image for creating this virtual machine, and I'm going to assign it some resources such as CPU and memory with 2 cores and 2 GB of RAM, and then I'm going to assign it some credentials so that I can access the machine, right? And then I have a cloud init here, which will do a set of instructions that I want to when the virtual machine comes up. So I want Apache 2 or HTTPD get installed, and I want QMIGest agent as well to run on this virtual machine. And then there are more things which I want so that I can monitor my virtual machine. So let's quickly create this virtual machine. So here I have a cluster. I have a 4-node Kubernetes cluster. I'm going to create this virtual machine on this Kubernetes cluster. So let's do that quickly. All right, so with that, my virtual machine is created, and I've come back to the platform UI. And here, once I refresh the list, I will see my VM goes into provisioning. So by the time my virtual machine starts getting provisioned, what I've done on the parallel is I've run an Nginx deployment. So just as Johnny said that your let's say your containers can directly interface to your virtual machines, and then applications running inside a virtual machine. So that is what I'm going to demonstrate here. So I have an Nginx deployment, which will have one pod as one replica here. So what I've done is I've already run it, and I've exposed this as a service so that we can access and see if it is running or not, right? So let's quickly look at if the service is present. So if you see, I have a Nginx service here where with service type as node port, and this is available as a node port on this port on the node which is running on. So let's quickly see if it is running or not. So I'm already running it. So it's running on this particular node on this particular port. So this is essentially a Kubernetes pod or container running Nginx in it. Now let's go and look at the virtual machine which we just started creating, right? So my virtual machine is still in the creation state, and if you see, by the time it gets created, I will quickly take you through the virtual machine instance view that which Platform 9 provides, right? So this view essentially gives you a complete view of your virtual machine, the name of the virtual machine, on which cluster it is running, in which namespace it is running, since it is a workload which directly runs on Kubernetes. Along with that, you can see how many resources that are assigned to this virtual machine. So in this, for example, for this virtual machine, I have given it 2 cores and 2 GB of memory. Along with that, I can see other properties such as the status of my virtual machine, how long it was created, the run strategy for the machine, that should it always run, should it be halted whenever it's created or restarted, and there are other run strategies along with it. Along with this, you can see labels and annotations that are present on this virtual machine. You can edit and remove these labels and annotations. And then on the side, you can see the events which are happening on the virtual machine. So if I do a refresh here, I will see what are the events that are happening on my virtual machine right now, and how is it progressing, right? So here I see there's a data volume which will essentially work as a disk for my virtual machine that is getting created, and that got created, and now what it is doing is it's pulling the CentOS image from the CentOS repository, and then it will attach it to this particular disk. And once that is done, the virtual machine is going to come up with that particular CentOS image, right? And here down, you can see that how many disks you have currently attached to this. So we can see that here there's one disk which is backed by a persistent volume claim on Kubernetes, which is of 10 GB. And you can see the source for it is this particular URL, right? And what I've done is I've already created a storage class on this Kubernetes cluster so that we can provision the requisite PVC, which will be backing this data volume or this disk on this particular for this particular virtual machine. So let's refresh this and see if my virtual machine has come up or not. So you see, the events for this virtual machine just got updated, and we see there are multiple events coming up that my virtual machine got started, the internal VMI, which is the instance of this virtual machine, is running, and now the data volume got created and get attached with the virtual machine, right? So, and if you see that it goes into a running state. Now let's quickly go and see if it is actually running or not, right? So what we do is we give a direct console link for this to access this virtual machine from here. So once you click here, the console link will take you to the virtual machine console itself, right? So let me quickly log in into my virtual machine, and from there, we'll move on. Okay, so I'm going to log in as a root user here, and I'm going to enter my password. Okay. All right. So I'm inside my virtual machine, and what I'm going to quickly see is that the cloud init script, which I had run, which I had actually added as a definition into this virtual machine, as a part of that, I wanted HTTPD service or Apache to get running on this virtual machine. So let's quickly see if it is running or not. So the cloud init script is still running, and it has not come up. So what we'll do is we'll set a watch for this, or what we can do something like this. So if you see, it's not currently installing, it's not able to install my HTTPD because there's a cloud init script already running, and because of which there's a YAML lock on the system. So we'll wait for a couple of minutes here before we see the HTTPD running. Till then, what we'll do is let's see if we can access the Nginx service or Nginx container which we created on the cluster, and we can access it from a virtual machine. So let's go back to the UI and see and go into the Kubernetes space from here so that I can look at my pods, because my Nginx is running as a pod. So we'll go to the Kubernetes space, and this Kubernetes space gives you a good view of how many pods, how many deployments and services you're running on your platform. And here you can see all the different type of workloads which are running on this platform, right? So here I've selected by default my cluster on which I'm going to create both my virtual machine. I've created both my virtual machine and the pod, right? So let's quickly search for the Nginx pod here, right? So this is my Nginx pod, right? Which came up as a part of the deployment, and let's look at the IP for this pod. Right? So the IP for this pod is 10.21.212.1. So this is a Kubernetes cluster IP, which is internal to the Kubernetes network. So I'll quickly take this, and what I did earlier is that we are able to access this Nginx pod over the internet from outside. But now we are going to see if this pod can, or this Nginx service can be accessed from the inside of the cluster and by the virtual machine, right? So what I'm going to do is run a curl command here, and use this particular IP to get to this particular cluster. Before that, let's quickly confirm the IP from the CLI itself. And you see there's a Nginx pod here, and let me quickly get the IP from here as well, so that we can match it against the UI. All right, so it's the same IP that's here, 10.20.223.129. So let's go and try to curl it from the inside of the virtual machine. So the IP is 10.20.223.129. And you see, this virtual machine, we can reach to the pod of the Nginx pod using the curl command. So this essentially demonstrates that the network, there's a connectivity from this virtual machine to the particular pod from the inside of the cluster itself. Now let's quickly look at if the HTTP service came up, and So our HTTPD service came up, which I added as part of the Cloud Init script. Now, what essentially we can do is we can just do a curl localhost and see if the HTTP service is working. And what you want to see if this HTTPD service can be accessed by an Nginx pod. So we'll go back to the CLI and we will go into this particular pod, right? So let's quickly do that. So I'll copy the name of my pod here and I'll do a kubectl exec IT and the name of the pod, and I'll do a /bin /bash. And now I'm inside this particular Nginx pod, and I want to see if I can access my HTTP service, which is running inside the virtual machine on the port 80, right? So let's go and quickly see and find out the IP for my virtual machine, right? Okay, so this is the virtual machine that we started, right? And let's quickly look at what IP has been assigned to this virtual machine. So the IP that is assigned is 10.20.225.239. So let's quickly do a curl command from here now. And 20.229 or 225.239. And you see, we are able to access the HTTP service from the Nginx pod. So this essentially demonstrates the two-way communication between the Nginx container and the HTTP service, which is running in the virtual machine. Now, let's quickly look at the rest of the features that Platform 9 Kubevirt UI offers to our users. So we have a couple of operations that as a user you can do on a virtual machine. You can start the virtual machine, you can stop the virtual machine, you can restart the virtual machines, you can pause a virtual machine. And these are like power operations that has been standard across the different virtualization platforms. And along with this, what you can do is, I just demonstrated using the console. Along with this, you can migrate a VM. So let's say if you want to put a node in a node on which this virtual machine is running into a maintenance mode, right? So what you can do, you can quickly just click on migrate VM, and what it'll essentially do is it will schedule a job to migrate this VM to another node which has enough CPU and memory and other resources to schedule your VM, right? And along with this, you can edit this VM. So the edit view provides you a simple view of how many cores and memories, and then you can edit the compute resources here. Along with this, you have advanced option here. So the first advanced option here is CPU pinning, which you can use to provide dedicated resources for your virtual machine. And here you can say I want one socket, two cores, and let's say 2 threads, right? So this will bring it up to 4 vCPUs. I want dedicated 4 vCPUs. So the calculation is sockets into cores into thread. That will give you exact number of vCPUs, how many vCPUs you want. Or you can give a set number of set amount of Kubernetes requests and limit to this virtual machine. So essentially, you can define either the CPU requirement in terms of Kubernetes requests and limits, or you can give it in terms of socket cores and threads, right? Along with this, you can do the same operation for your memory as well. So you can configure your memory requirements as well here. And here we have at last is a delete virtual machine. So this will essentially delete this virtual machine. So let me quickly delete this virtual machine to complete the life cycle of this for this VM, right? And it's pretty quick to delete your virtual machine. So it takes a few seconds and the virtual machine will go away. What I'll by the time it gets deleted, what I'm going to do now is get out of this pod, which we were clear inside it, and I'm going to schedule a Windows virtual machine. So the virtual machine which was currently running was a CentOS Linux virtual machine. I'm going to run a Windows virtual machine as well and see if we can run Windows virtual machine on the same cluster or not. So let me just quickly run it. Again, a YAML and a Kubernetes object. So kubectl create -f and the name of this particular YAML. So it's the Windows VM demo. And what it'll do is it will schedule this virtual machine to be created. And along with this, let's quickly look at the definition for this. So what I've done is I've created a new namespace for my virtual machine in which this virtual machine will get created. Along with this, I'm creating a persistent volume claim with name WinHT12 with 35 GB of storage. So this will act as a hard disk for my Windows virtual machine, right? And along with this, I have my whole definition of my virtual machine, the compute resources, the link for the virtual machine. So what this source reflects is that the virtual machine is going to be created directly from an HTTP source from the Microsoft website, right? And then you have other properties of the virtual machine here. So let's quickly go back to the UI and see if the virtual machine appeared here or not. So if you see, the test VM is gone because we deleted it a minute back, and now the Windows 12 machine is trying to get provisioned, right? So by the time this virtual machine gets provisioned, because it'll take a few minutes, since it's going to pull up the Windows image from over the internet, let's quickly go and look at how someone can use this Kubernetes and Kubevirt on Platform 9, right? So essentially, there's nothing much a user has to do to run Kubevirt on Platform 9. What they have to do is they have to create a Kubernetes cluster. So the Kubernetes cluster is pretty straightforward. You come here and you have to add your virtual machines beforehand or your physical machines beforehand and register them to the Platform 9 Kubernetes control plane. Right. Once you do that, you can choose which kind of cluster you want. So let's say if I want a master cluster, I can just go with a master cluster, right? And then I can go about the flow of creating the cluster. Once my cluster is created, what I'll get is basically the cluster gets running, and I have the whole information about my cluster. So what I've done is this cluster is already running here. So let's look at the cluster itself. So this is a 4-node cluster with single master and 3 workers. And the way Kubevirt is enabled on this cluster is in two ways. One, you can enable it during the cluster creation itself by just using a checkbox, and that will install Kubevirt. If you have not enabled Kubevirt during the cluster creation, what you can do is come to the add-ons. So essentially, Kubevirt runs as an add-on on Platform 9, and Platform 9 runs a lot of managed add-ons along with Kubevirt, such as Core DNS, Kubernetes Dashboard, Metric Server, Prometheus, CD Backup. All of these are add-ons on Platform 9 Kubernetes clusters. So Kubevirt essentially is also an add-on. So I see here all of my add-ons are healthy on this cluster. Now what I can do is I can just come here to the add-ons page for this particular cluster, and I can go into the edit view for it. And here I can enable or disable my Kubevirt. So since my cluster is already and my Kubevirt is already running, I won't disable it because we've scheduled a Windows machine right there. But essentially, you can enable or disable Kubevirt with a single click. There's the prerequisite to that is Luigi, or which is we call as advanced networking operator. That is developed by Platform 9, which helps you enable the advanced networking capabilities such as Multus, SRIOV, OVS, DPDK, and you can use all of those networks on this cluster. So we already have Kubevirt running. So let's quickly see if I had to create a virtual machine from the UI itself, how would I do that? So what I would do is I'll just come back to my Kubevirt space, and I will come into the all VMs view. So this is where I see all of my VMs, and we see our Windows 12 machine is still in the provisioning state. So by the time it comes up, let's create a virtual machine here. So what we can do is we can click on the create virtual machine, which will give us a module where we can define and go through the flow of creating a virtual machine. So let's give this VM a name demo, and we can create this virtual machine on another cluster. So let's say this particular cluster, and I will choose the default namespace for it. And I will choose run strategies always, so that it just as soon as the virtual machine starts, it is not in a paused or stop state. It starts running. Right. Next, you can define is the storage for your virtual machine. So what I'll do is I'm going to define storage for this virtual machine. Let's say I want a 35 GB of disk for this virtual machine. I do not have a storage class. So let's change the cluster on which I can run this virtual machine. So I'm going to run it on the KV cluster. and quickly choose the default as namespace. And coming back to the storage section, I will give this as size 35 GB of disk. And then here I have a CSI storage class, which will give us the actual persistent volume claim for this virtual machine. Now, this virtual machine needs to be created using a operating system of the user's choice. So here I will choose a CentOS, choose to create a CentOS VM. And I want this VM to be created from this particular image, and this image will be imported over the HTTP, right? So once I do that, I will go to the next page. So this is where I define my compute resources for my virtual machine. So let's say I want 1 core and 1 GB of memory for this particular virtual machine, right? And then I go on to the network tab. So this is where I see my networks, whichever networks I have created. And there's a binding mode for the pod on which the virtual machine runs. So if you want to enable live migration, the required binding mode is Masquerade. But if that is not required, then you can use a bridge binding mode as well. And you see on this particular cluster, I have enabled OVS and SRAV as well. And and on all those networks are now here appearing here. So I can choose any of those networks, and those networks will be attached as additional NICs on my virtual machine. So there will be a standard NIC always that comes up on the virtual machine. But if you want to attach any additional NICs to take advantage of the advanced capabilities of Platform 9's advanced networking, you can do that. So you can choose to add an OVS NIC or SRAV NIC on this. Or any other NIC, which depends on the use case. So I'm not going to use any additional NIC, so I'm going to just have it as a default NIC, and I'm going to go click next. So here I can add my cloud init script, whatever I want to run as a prerequisite when my virtual machine comes up. And then I have the advanced configuration. So this is where, as a user, you can, though you are creating virtual machine by default, but Kubevirt as a project is very vast, and you have a lot of specs in the virtual machine custom resource definition, some of which you might not find in the UI, right? So as one advanced user who who really wants to test out the limits of Kubevirt, you can add your additional configurations for your virtual machine here. And then you go next, and then you hit create for this virtual machine. And this will take you back to the virtual machines view. So if you see, my Windows 12 virtual machine came up. So let's quickly have a look at that. And it's in the running state. What I'll do is quickly go to the console and see if it is indeed running or not. So what you see here is my Windows 12 virtual machine is running. And the image is of a Windows Server 2012. And then just as any other hypervisor platform, you set up your Windows virtual machine. You can go and quickly now set up and install your operating system on this virtual machine, and then you can keep going and start configuring your virtual machine here itself. So yeah, that's pretty much which I had today to show this demo. So I'll quickly stop my sharing my screen.
Fantastic. So Anmol, that was a stellar demo. You covered pretty much everything that a typical Kubernetes DevOps engineer would love to see. So to summarize what Anmol has shown, first thing, VMs are first-class citizens in Kubernetes. They run inside a namespace, they run like a workload, and they consume PVC like a typical pod, and they run side by side along with the pods. And not only that, you can even consume the APIs or the services or the endpoints exposed by the VMs and vice versa. So VMs can talk to pods, pods can talk to VMs. And that was very clearly visible from the demo that Anmol has shown, where we could hit the HTTPD endpoint in the VM, which was running Apache. And the VM could do a curl against the Nginx pod exposed as a service or directly using the pod IP. So it's a very, very powerful scenario where you can mix and match legacy workloads with modern microservices without compromising, without any trade-off, where you have all your workloads running under the context of Kubernetes. Now, what can this really deliver? Well, first of all, why do customers move to Kubernetes? right? The first one is it gives the ability to do efficient operations. You can very quickly deploy workloads, and you can iterate over it, and you can perform CI/CD, you can leverage GitOps, you can do declarative management. Now, guess what? All those benefits can be seamlessly extended to VMs, because VMs are also now a part of Kubernetes. So you can technically extend your agile operations and DevOps practices to manage VMs, just like the way you have been managing your other workloads, like pods. So that actually brings us to the end of the session. But one technical question, Anmol, is KVM a prerequisite, or can customers already running Xen or any other hypervisor or an emulator can leverage Kubevirt?
So I think Kubevirt is developing the abilities to do that, but right now I think the most standard one is KVM, because it has been tried and tested for the longest time, right? But you can still choose to use whichever, not whichever, which the one supported. Yeah, I think that would be the short answer for it.
Cool. And you mentioned about the add-ons, the network add-ons that Platform 9 has invested in. Can you talk more about it? Because that actually sounds very interesting and looks like it is the value addition that Platform 9 brings.
Absolutely, yeah. So Platform 9 has developed in-house advanced networking operator called Luigi, right? So this operator lets you deploy a couple of plugins. So essentially, everything that it deploys a plugin inside it. Now these plugins can be SRIOV, OVS, BPDK, or host networking templates, or any other plugins that we have, right? So let's say if you want to leverage fast networking for your virtual machines, right? And SRIOV has been present for the longest time. I think probably almost more than 10 years it's been out there in production. So you can use the same SRIOV on Platform 9 Kubevirt using the advanced networking operator. And essentially what you just need to do is, just as I created VMs using the YAMLs, you can configure your network similar to that. You can just give your network definition in a YAML, and you can deploy your SRIOV. And once you do that, then you can choose which virtual machines can use this SRIOV network or not. Similar to that, you can use the OVS, which is Open vSwitch, to create multiple NICs for your virtual machines, so that you can have east-west traffic on your network, on your cluster. And along with that, you can enable BPDK, which will give you hard acceleration in terms of the networking, because it would use your user space rather than the kernel space for your VMs, right? So the advanced networking operator gives you all those abilities, and it is directly built into Platform 9. You just need to click enable, and it will just enable the operator and install all the prerequisites. Otherwise, if you had to enable SRIOV or OVS on a regular Kubernetes cluster, you might take probably an hour or more than that just to enable the operator and see if the pods are coming for those things or not. And along with that, you can install Multus, so that you can have multiple NICs, which is a basic for running SRIOV and OVS, right? So yeah, the advanced networking operator takes away all that hassle in just one click, and you don't have to do anything other than enabling it to
Awesome.
have multiple networks.
So as someone familiar with Kubernetes, is this comparable to the CNI plugins?
Yes, absolutely. Yeah. It is that. So basically, Multus is also CNI plugin, and SRIOV and OVS also. Everything is a CNI plugin. Yeah. So essentially,
Cool.
you would have to deploy all of them by yourself, but here you do not have to do that, and you can just create those YAMLs, and that's it.
Cool. I have seen an audience question. So is Kubevirt free? The answer is absolutely. It's an open source project. You can actually look at kubevirt.io if I'm not wrong. That's the URL for Kubevirt.
Yes.
There are a lot of contributors. There are a lot of platform companies investing in it, and there is a huge ecosystem around Kubevirt. So it is absolutely free. It is like any other open source project, and you should check out kubevirt.io. Excellent. So, Anmol, thanks again for that wonderful demo. It clarified a lot of apprehensions and doubts that I had personally. And it was thrilling to see how pods and VMs could talk to each other, and the value addition that Platform 9 brings by creating the network layer that enables this interoperability. So, and it was also fun to see a Windows VM come up. I never thought you could actually do that in Kubernetes. So clearly, a lot of work has gone into the demo. So Anmol, I know what it takes because I keep building this demo. So thanks for putting that
Yes.
effort in creating that wonderful experience and the wonderful demo. So that brings us to the end of this episode of the State of Cloud Native. Thanks for joining us. This recording will be available on Platform 9 social media channels, including YouTube, LinkedIn, and other channels. So stay tuned for the next show on the State of the Cloud Native series that we are running. We have very interesting content lined up for the next few months. So thanks again. And yeah, Dawn, are you there? Do you want to wrap up?
Absolutely. Thank you so much. Thanks to both of you for a really great session. In fact, we have a comment from the audience that the session was just awesome. Can I get a notification mail regarding such sessions through email? And up on the screen right now, you see sign up for our newsletter. Just go to platform9.com, State of Cloud Native. And we do have a form there where you can sign up for our newsletter and get information about upcoming live streams as well as upcoming webinars. As Johnny mentioned at the top of the live stream today, we did do a recent webinar on VMs and containers, and we do have another webinar coming up at the end of the month. So please feel free to go ahead and check us out at Platform 9. Keep an eye on us on social media, on LinkedIn and Twitter, YouTube, and so forth. And you can keep up with us and our webinars and our live streams. Thanks, everyone, for joining us today. And we look forward to talking to you all soon. Thanks, guys.
Awesome. Thank you.